Hi Year 12s, I'm going to go through the extension questions from the homework on differentiation. Okay, so question 15 gives us a graph and then it wants us to state what the gradient it is. Now notice this graph is y is f dashed x, so this is the gradient function. So whatever y value we've got here, that is the gradient. So the gradient at A is in fact 0 because we're on the x-axis there. Right, and then it asks, is the function increasing or decreasing at B? So we can see that at B, the gradient is positive, yeah, because this is above the x-axis. So this is the gradient function. We're not looking at the gradient of this curve. The y values here are the gradient. So it's a bit like what we did when we first looked at this topic and I made you draw lots of really hard to think about graphs. So the gradient is a positive number, and so that means we have an increasing function. Okay? And then finally, for part C, you get to do what we did at the start, which is sketch the graph of y equals f of x, the original function. This is the gradient, and we do the original function. So I wonder if you remember. So we had to think about, we know that we're going to have turning points where the gradient is 0. So we can see here that the gradient is a negative number, so we're going to be going downhill till we get to A, then the gradient is positive till we get to 4. So we're going to be going uphill for this section, okay? And then we go negative gradients again underneath the x-axis. So for this section we'll go downhill and then we go uphill, okay? So let's try and do that. So we're going to go, not very sure where we're going, but we're going to go downhill as far as 1, okay? And then we're going to go uphill till we get to 4. So this is my first go. Then I know once I've got to 4, I'm going downhill again till I get to 5. And then I'm going to go uphill after that. Okay, so wherever these are, it's a bit wonky, wherever these gradients are 0, I have a turning point, a stationary point. Okay. Bit far away, but hopefully we get roughly the idea. Now what we don't know is whether our graph is high up in the air here, as I've sketched it, or maybe I should have drawn it low down, going a bit above, a bit below. Okay, we don't know where it should be placed, but it will be this approximate shape, but it could go anywhere, translating up or down. Okay. Now, looking at this, we can see that we've got getting bigger and bigger and bigger positives, so the steepest point ought to be where I've got my highest positive numbers. So this ought to be the steepest bit, okay? And with the negatives, it's not very steep there, so that maybe I should have done that a bit flatter, okay? Because it's very small negative values, isn't it? So if I smooth that out, that might be a bit better. Okay, and here we've got very steep negative values, very large in magnitude negative values, so we've got a very steep bit of graph, and that seems to work. Okay, they're always hard to think about, so don't worry. Okay, let's have a look at number 16. So find the coordinates of the point on the curve, this thing, where the gradient is 5. Okay, so we want to know where is the gradient 5. So we know gradient is dy by dx, and we know that has to equal 5. Okay, now in order to differentiate, to get our gradient, we need to put that in a nicer format, don't we? So we've got y is equal to root x plus 3x, so that's x to the half plus 3x. So then dy by dx, hopefully will be coming relaxed about this now. It's a half x minus a half plus 3, and we know that that has to equal 5. Now, I'm going to be solving an equation, so now I don't like this format. I much prefer it back into fractions and roots. So this is the same as a half times 1 over, because of the minus, and then a half means it's root x, so 1 over 2 root x. If that confuses you, if you think of it, we've got a half times x minus a half, so 1 over root x. And so we times the numerators times the denominators. Okay, plus 3. Alright, and now we've got an equation to solve. So we're going to subtract the 3. Now, we don't like having things in the denominator, so we multiply both sides by 2 root x. Divide both sides by 4. Square both sides. Brilliant, so now we know what x is, but we were asked for the coordinates. So that doesn't just mean x, that means x and y. So we need to substitute back in to root x plus 3x. So root 16th plus 3 times a 16th. So root of 16th is a quarter plus 3 16ths. So that's going to be 7 16ths. You are completely allowed to use your calculator. So the point is 1 16th, 7 16ths. Okay. Right, and that's appropriate for question 16. So, number 17, last one. Find the gradient of the graph of y is 1 over 2 root x at the point where the y coordinate is 3. So find the gradient, so we're wanting to know dy by dx, where y is 3. So first of all, we know that y is 3, so 3 is equal to 1 over 2 root x. So this is similar to what we just had, the sort of equation to solve. So we multiply 3 by the denominator, we divide by the 6, and we square both sides. Okay, right, so now we need to know what the gradient is, so we want to differentiate. So we've got y is 1 over 2 root x, remember that's a half times 1 over root x, so that is a half times x to the minus a half. So when we differentiate, okay, then we're going to have a half times, bring the power down, and subtract 1 from the power. So we've got minus a quarter x to the minus 3 over 2. Now we want to know what that gradient is when x is 1/36. Okay, so now we can substitute in our 1/36 to the power negative 3 over 2. So you can manipulate that in your head if you want to, okay, but I think it's easier when it just says find, you can just type it in. So we've got minus a quarter times 1/36 to the power minus 3 over 2. Okay, so we get minus 54. So very large and negative.